Today we will start with our lesson, chapter 31, Lenses. Girls, this chapter is very important. Uh, Listen to me, it's not hard, it's not difficult. Always the students, they think that it's hard and difficult, but no. It is hard and difficult if you don't understand and you don't practice in drawing. If you understand and you practice daily and you solve paper 4 questions and paper 6 questions, this lesson will be easy for you. Okay, let's start. Lenses. Lenses are used in optical instruments. Look here. What do you see? Different objects or instruments. Camera, eyeglasses, microscope, telescope. In all these instruments, we have what? Lenses inside them. So today we want to study and to understand lenses and why do we use them inside optical instruments. Let's start. Now we have two types of lenses: convex lens, concave lens. Convex and concave. Convex looks like that. It is thick from the middle, thin from the sides. Okay, from up and down. Concave the opposite. It's thin from the middle and thick from up and down, or from the two sides. Convex lens has another name, converging lens. Why do we call it converging lens? What does it mean, converge? Converge, it means what? That all lines, they are going to the same point. They are going toward each other. Okay? This is the meaning of converging. That's why we call convex lens converging lens. Why? Look what happens. If in a case that parallel rays reach this lens, what will happen to these rays? All of them, they will meet at one point. We call this point principal focus. Okay? That's why we call it converging, because it combines all the incident ray at one point. Concave lens, the opposite. Its name is diverging lens. Diverging because what? All the lights, they diverge. They move in different directions. They never meet. We said we call it diverging lens because it diverges the beam of ray. Okay? Example for a concave or diverging lens is what? You know these spy holes in the doors? Yes, it's an example of concave lens. And the example for convex lens is what? A magnifier. Okay, let's see here. Convex lens, as we said, its name is converging lens. The rays converge to a single point. If they ask you why the name of a convex lens, converging lens, why? Because the rays of light, they converge to a single point, or they meet at a single point if they come parallel from the object. Okay. Concave lens, we said we call it diverging lens. Why? Because the rays diverge and appear to come from a single point. They appear that they come from a single point. We will talk about this later. So they diverge, but they appear that all of them coming from a single point. This is not real. These are dashed lines extended of these rays. Okay, so we don't have here a point that they all meet together at it. Let's now talk about the terms we use it to describe lenses. Okay? Look here, please, to understand and try to memorize them and understand them. The first thing we have it in both lenses is what? Optical center. It is the center of the lens. The center of the lens, we call it optical center. So it's the center of the lens. We have it in concave and we have it in convex. The second thing, principal axis. What is a principal axis? It is a straight line perpendicular to the lens and passing through the optical center. Okay, so not any straight line, no. We have only one principal axis. A straight line passes through the optical center. Okay, and it's perpendicular to the lens. Here is a principal axis and here is the principal axis. Good? Let's continue. Now we have also principal focus and focal length. These for a convex lens, we want to study them for a convex lens. Here's a convex lens. So rays passing through convex lens parallel to the principal axis converge to the principal focus. So we said before that convex lens, we call it converging lens. Why? Because it converts all the rays toward one point. We call this point principal focus. Okay, the name of this point where all lines meet, what is it? Principal focus. And always this point is where on the principal axis. Okay, a convex lens has two principal foci. Why it has two principal foci, not only one? Who knows? Because I can you put an object here or a source of light and also from this side and it works from both sides, not the same as mirrors. For example, mirrors, we can only use the mirror from one side, not from both sides, but the lens, no, I can use from any side I want. That's why each lens has two principal foci. Okay, now the focal length is what? It's the distance between the focus and the optical center. So, where is the focal point? Here's the principal focus, sorry. So the distance between the principal focus and the center, we call it focal length. Focal length. Girls, all these notes and terms are very important. So again, what do we have? First of all, we have here what? Optical center. Optical center, it's the center of the lens. And we have principal axis. It is the axis that passes through the or the straight line that passes through the optical center and is perpendicular to the lens. And we have principal focus where all points meet. And also we have focal length. It's the distance between the principal focus and the center of the lens. Now for concave lens, look here for a concave lens. As we said, concave lens, we call it what? A diverging lens. Okay, why? Because it diverges all the rays, the beam of rays. They go away from each other. They don't meet at any point in here in front of the lens. But where do they meet? Behind the lens. Here, behind the lens they meet. Now, as I said, these lines are not real. I just draw an extended line from each ray and I see where do they meet, and the point they meet, they form a principal focus, but this one is not real. It's a virtual principal focus behind the lens. Okay? Good. And the same thing, optical center, principal axis, focal length. We have all these and principal focus, but here it is not real, it is what? Virtual. We have here a fact or a rule that the more curved the length, the more curved the lens faces are, or the more thickness of the lens, the smaller is the focal length. The smaller is the focal length, and the more powerful is the lens. So it's better to what? For a lens, if I wanted to give me a better image or to be more powerful, I have to use what? A thick lens. Okay, so shorter focal length and what also? It gives me more or powerful image or better image. Good? I hope that everything is fine till now. The first thing we want to do it here is the practical work in this lesson is to find the focal length of a converging lens. We have an experiment. We do it to find the focal length of a converging or convex lens. We use the fact that rays from a point on a very distant object at infinity are nearly parallel. What does it mean? Now, girls, we said in a convex lens, the rays that you have to come parallel toward the lens. If they all come parallel to each other and they reach the lens, what will happen to them? They will meet at one point. We call it the principal focus. Okay? So now if I have any normal object, for sure, not all the rays that are coming, they will be opposite, they will be parallel. Some of the rays will move toward up, toward down, in so many directions. So here, always when the object is far away, we say that this object at infinity, okay? For sure it's not at infinity exactly, but it is far, far, far away from the lens. So this very distant object, what you will feel, it appears that all the rays, they are moving parallel toward the eye or toward the lens. So if the object is close to your eye, you will see that the rays are moving in all directions. If it's away a little bit, it's almost parallel. But if the object is far away, very distant, or we can say it is at infinity, in this case, yes, the parallel beam, the beam will be parallel, and we can use this case to find the focal length. Okay, only in this case we can find because here or here they will not meet at the focus point.